Okay, so we're talking about this lab and its calculations, okay? In this year's TUMS lab, we used two arbitrary values, 0.4 molar hydrochloric acid, okay? And we used 0.5 molar NaOH. However, we standardized it. So for this class, we used KHP, and what was your value for the amount of volume of base needed to neutralize the KHP? 10.29. So it took 10.29 milliliters of the NaOH to neutralize the KHP. Now, we decided arbitrarily to have 0.005 moles of KHP. That was something we decided when we set this up. You say, well, why did we decide 0.005 moles? Because I wanted to titrate about 10 milliliters of this. And about 10 milliliters of 0.5 molar, if in fact it was, would be 0.005 moles. And we found out, using the formula mass of KHP as 204, that was 1.02 grams? Okay, so that was easy. Okay, well, it took that amount of base to neutralize that acid. Well, what do we know? At the equivalence point, and we used an indicator, that must be 0.50 moles of hydroxide. Oh, great. Let's go find the concentration. Molarity is moles over liter. The moles is 0.005. We had 0.005 moles of KHP. It was completely neutralized. I'm sure of it because KHP is a solid, it's not reactive, okay, and it's got a big molecular mass. So I'm very certain that was the moles of the acid, and that's the moles of the base needed. Now, the volume dropped of the base wasn't 10. It was more than 10. Because this was weaker. So in any case, let's go find the volume. Has to be in liters. So move that decimal place 3 times, so 0.01029. And we put this in our calculator to find the new molarity, and I get 0.4859. I'm going to keep that number that way. I'm going to carry that many numbers, even if, okay, I don't want to round early at the end of this. I want to keep as many possible. Okay, so we don't have 0.5 molar NaOH. What we have is 0.4859. It's less than I made. I carefully made 0.5. Why is it less? Because sodium hydroxide reacts in the air in the solution, and it reacts in the air as a solid. So I had to verify it. That's what the standardization does. This lab is dependent upon what? Knowing the concentrations of these acids and bases. Titration, by definition, is using a known amount of one chemical to get the concentration of the other. So I better know what this is, and that's what we did in the first part of this lab by standardizing, okay? And we use KHP because, hey, it's a solid, it doesn't react, and it's a high molecular mass. And so good. I'm going to take off this data. Now, by the standardization, I know that concentration. Okay. All right. We did a second titration. We crushed the tablets. Okay. We added some water. Then, we added 100 milliliters of 0.4 molar HCl. Well, what does that mean? Well, don't forget, 0.100 liters of the volume of acid I gave you times its molarity, 0.4 molar, okay? If you do that math, 0.1 times 0.4, it's 0.04 moles of H plus were added. Hey, that's this arrow. That's important. That is the amount of moles of total H pluses. We need that number. Okay, how much is the excess? Well, that depends upon, remember the target was 0.03 moles. We decided if each tablet was 0.750 grams, we'd use 2, which is now 1.50 grams. Through a stoichiometry, we figured out it takes 0.03 moles to neutralize it. That would be the target if the tablets are what they say they are on the label. I can do this. We don't know for sure. It might be less or more. Okay, so how much of the excess do we have? We don't know for sure, party people, so that's what we're after right now. So, I know the 0.04 moles are added. I'm going to get rid of this right here. And now, what I'm going to do, I know some of it was neutralized. How much? We all don't know. We did a second titration. We put back in the pH probes. Okay? And we all got graphs by plotting pH over volume. We got and found this volume, the equivalence volume. I don't care about the pH. So, what was your equivalence volume? 22.5. Okay, 22.5 milliliters. That was how much of this standardized base was needed to neutralize the excess H plus. So what I want to find is how many moles of hydroxide were needed. That'll tell me how many moles of excess H plus. So how do I do that? Well, that's very simple. Take our 22.5 milliliters, which is their equivalence volume, convert it to liters, because liter times molarity gives you moles. You guys did this for every single lab, last 3 labs, right? So we'll take our 0.4859 molar concentration that was standardized. We're going to times it by this in liters, 0.0225 in liters. And let's see what that gives me. That's going to, molarity times liters gives me moles of hydroxide. So 0.4859 times 0.0225, and I get 0.093. 0.093, I think. See if I get more numbers here. I think my big finger error here. I'm sorry. Woo! Not even close. Yeah, not even close. Sorry. I got 0.01093. Okay. Always check my math. And that's moles. Moles of what? What was added? Moles of what? Moles of hydroxide. But wait a minute. Doesn't that equal what?
Oh, it's 4.5.
Isn't that the moles of H pluses? By finding this equivalence volume and timesing that volume in liters by the molarity of your standardized base, you got the moles of hydroxide. Well, party people, that, my friends, is the moles of H pluses, because one hydroxide will neutralize one of those H pluses. Really, it's a hydronium ion that's sitting in what? The solution as excess. Party people, you just solved your excess what? That's your excess amount. So, okay, what do I do with that? You added 0.04. I want to subtract 0.01093 backwards. I want to subtract that to know exactly how much H pluses I add. So I'm going to take 0.04 minus my excess back titrated amount, 0.01093. What is this going to give me? This is going to give me the exact amount of H pluses or protons that were needed to neutralize my tabs. 0.04 minus 0.01093. And what I get is 0.029, 0.029, 0.02907. And this is moles of what? H plus. Party people, what you just solved for is the exact arrow down. The target was 0.03. This lab group got 0.09, little less, pretty close for this group. Okay, but now, how do we work this back to grams? Well, we got to do some stoichiometry. Pretty fun. Okay, so here we go. I'll pick my 0.29707. This is moles of what? H plus. What do I know? 2 H pluses makes 1 carbonate. I got to get rid of my H pluses, so the 2 H pluses go on the bottom. 1 carbonate. What else do I know? For every 1 carbonate, there's 1 calcium carbonate. So essentially, I'm dividing by 2 to get the moles of calcium carbonate. But I want grams. Where's the mole? On top. And I know it's 100 grams. And we'll see what we got here. 0.097 divide by 2 times 100. That part I could have done. And this group got 1.45 grams. But that's for 2 tablets. Divide by 2. And you get 0.727 grams of your active ingredient. You want to convert that to milligrams. Okay, you times that by 1,000. And so party people, from this work and a lot of effort, this lab group got 727 milligrams in their tablet, which is under the what? 750 it said. And if you were very, very meticulous in your titrations, okay, and I did a great job of making those solutions, you can see, well, Mr. Grotsky, you're off by the NaOH, that's fine, okay? We can say with very large confidence that it's under the 750, the extra 750, remember that's milligrams, that they projected, all right? So it said 750, UK. Now what did you guys get?
I got 700.
54, pretty darn close. Okay, remember, if you average all these tablets together, they probably come out. They don't put a lot of effort to making sure it's exact, but a pretty good represent, and the FDA would say, hey, plus or minus, and they would do a bunch of different ones and say, hey, you guys are close enough, okay? And remember, it's chalk, all right? So that's the lab. The question is, can you write it up and understand every part of it? And that's what I want you to do, okay? I need net ion reactions. Remember, in this lab, there's 3 conclusions. There's 3 procedures. There's the design, which got us to these 2 arbitrary values. Then there's the making of the solutions. That'll be tomorrow. Then there's what you just did. Hey, we crushed the tablets. We added the acid. Oh, I'm sorry. We standardized first, picking a certain amount of KHP. We used an indicator for an endpoint. Then we crushed the tabs, added the excess acid, titrated back, but that time we used a pH probe. Why? Because the solution was colored. Hard to see indicator changes, so we used a pH probe to get the equivalence. Okay? So, love the lab, as you can see. There isn't much that I don't love about chemistry, but hopefully that helped you understand that.